Good morning, professors. I am Subramaniam, working as assistant professor in SNS College of Technology. In this session, we are going to see about on the building components about the bearing capacity. Bearing capacity means whatever the building has been constructed, the soil must have the strength to bear the full load of the construction building itself. So, even though it's a single floor or double floor or many floors, on the building has to be bared by the soil itself, such that it does not gives any shake or any cracks for the building itself. So in this bearing capacity, the main things we have to see is the foundation pressure and the shear failure itself. So foundation pressure exerted by the foundation on the soil surface. Also we can see this says whenever the side by the building, if there is any river or else any other earthquakes comes, means the building shake must not be there, and due to the building any railway tracks also nearby, means it will be having some sheerness for the building itself, which will be giving some failures. So this has to be avoided, or this has to be prevented by the soil bearing itself. Next was there are types of bearing capacities are the net safe bearing capacity, or the net ultimate bearing capacity, an ultimate bearing capacity, and the gross safe. Gross safe bearing capacity, net safe settlement pressure, and net allowable bearing pressure itself. On according to this, all 6 bearing capacities, we have to design the construction of the building itself. And the factors which are affecting for the bearing capacity of the soil is the first one is the foundation characteristics and the environmental characteristics. Also, we see about the soil properties and site conditions. So, foundation characteristics says foundation depth and the foundation width. In the earlier chapter we seen about what is the foundation depth, what is shallow foundation and structural foundation itself, and sub foundation and the superstructural foundations. On depending upon this, we must have the foundation characteristics and also the environmental conditions. There is a frost action, also dynamic motions and earthquakes are there. And soil properties, we see the collapsible and expansive soils. The soil must be hard enough to bear the building itself. Next we see about compare the soil bearing capacity and variations. There is a unproportional increase and also linear variations. On these must be proportional, both must be as a common way to have the solution itself. So unproportional increase or linear variations must be there, and cohesive soil or cohesive soil. Next we see about the foundation width. So foundation width effect on the soil bearings. So width of the proportional capacity must be tallied with the width of the independent capacity. So there is a cohesiveness or also cohesive soil. So both the width must be proportionally equal. And we see about the soil strength and the foundation depth itself. So greater bearing capacity or deeper foundations. For the greater bearing capacity, must have deeper foundations. So if you say about the bridges, it must have deeper foundations, such that it has to bear the large amount of the weight of the 2 pillars itself. Also declined bearing capacity must have the shallow foundation itself. So here you can see there will be no much load will be added, but there will be slope will be there. So that in the weak soil also you can have shallow foundations, but in the strong soil you must have a deeper foundation itself. And also there must be water flow strength. So water tablet or impact on the bearing capacity, there will be water flow will be there. So high water table causes uplift of the problems, and high water table also says the causes construction problems and the subsurface soils also. So high water table causes seepage problems and surcharge soils also. This comes to the frost impacts on the soil bearing itself. So frost impact means there is a reduced capacity or slit vulnerability. So reduced capacity gives the soil bearing strength weakness, and whereas the slit vulnerability gives a low coefficient soil affected itself. So this was the frost impacts on the soil bearing capacity itself. How to manage all these soil stabilities is, if the dry soil means offers temporary stability but prone to collapse itself, whereas a moist soil means it causes structural shifts and long term of damage is there. So to manage the stability constructions, we have to provide it in such a way that is must have a subsurface voids or the critical depth itself. So on these things, soil bearing capacity reduction must be reduced. So with this, we come to the end of this chapter. Thank you for listening.